All right, so let's look a little bit deeper into this second approach. First we had the confidence interval approach. Now we're going to do the hypothesis testing approach. Now, as a kid, I used to love to read detective novels. And it struck me that there's a lot of similarity between how we handle how our legal system handles this question of whether somebody has committed a crime or not, and the formalism of hypothesis testing. So let's take a look at this situation. So what we've got is we have an individual on trial, and the question is, did this individual commit the crime? And since most crimes are committed by men, I used he. So did he commit the crime? So what do? We get evidence, and we bring this person to trial. Now, the truth of the matter is that the person actually is innocent or did not commit this crime at all, or the person is guilty. What we do is set up a jury, and then the jury decides whether the person is not guilty or guilty. The person is assumed innocent, so the jury just decides whether not guilty or guilty. If the jury decides the person is not guilty when in fact the person is innocent, then the jury is doing the correct thing. If, on the other hand, the jury decides the person is guilty when the person in fact did commit the crime, then once again the jury is doing the correct thing. The jury is only going to decide guilty or not guilty. So potentially you can make one of those two decisions, but in reality, after the trial, only one of those rows pertain. If, on the other hand, we're in one of the off-diagonal situations, then the jury has made a mistake. So finding a guilty person not guilty or finding an innocent person guilty, those are the mistakes that a jury can make. Of course, at most you're going to make one of those mistakes, but potential is there for either of those mistakes to be made. Now, instead of deciding whether a person is guilty or not, we're going to decide whether the mean of the population is some specified value. Okay, so mu naught would be 337 or whatever it was. Now, the evidence is going to be the sample. We're going to take our sample of size 49. That will be our evidence. The trial is going to be the analysis we do. So we'll calculate the sample mean, calculate the sample standard deviation, etc. So the person about whom this trial is all about is now the population. And either the mean of the population is a specified amount or it's not. Okay? We are the jury, and we're going to decide not to reject the null hypothesis, which is that mu is equal to mu naught, or reject the null hypothesis that mu is equal to mu naught. That's what hypothesis testing is all about. Okay? We are going to be faced with a hypothesis that the mean of the population is a given amount, and we are going to decide to reject that hypothesis or not on the basis of a sample from that population. Now, let's look at these possible errors. We've got this very imaginative way of addressing them by calling the first one type 1 and the second one type 2. Now, going back to the innocent and guilty, we are going to be now interested in determining the probabilities of making these kinds of errors. The Romans used to say, better that 10 guilty men go free than that one innocent person be found guilty. So they had this 10-to-1 ratio of these probabilities of these types of errors. Now we've diluted that a little bit. We value life possibly a little bit less, because we say better that 8 guilty men go free than that one innocent person be found guilty, but that's okay. So here in hypothesis testing in probability in statistics, we label these probabilities as alpha or beta. So the probability of a type 1 error is alpha, and the probability of a type 2 error is beta. So it's the probability of rejecting the null hypothesis when it is true is called alpha, and the probability of a type 2 error, which is not rejecting the null hypothesis when we should be rejecting it, is beta. So in both instances, we'd like to make these as small as possible. This is very similar, of course, to what we did with diagnostic testing, except with diagnostic testing, we sort of took a more positive view on life, and we spoke about sensitivity and specificity, and we would have liked both of those to be equal to 1. Here, we are very negative about things, and we look at making errors, and so we would like to make these as small as possible. In terms of beta, sometimes we look at 1 minus beta, and that's called the power of the test. So these are the probabilities of making these errors. And that's the formalism of hypothesis testing.